Thank you. Green button is forward, right? Hello, everyone. Good. Cleanliness and goodliness. I thought it would tickle the brain a little bit with the word goodliness. I was going to call it dirty data done dirt cheap, but John Krosnick said he wanted that title for river samples, so I am doing goodliness. And we're going to look at data cleaning. I'd like to thank my co-authors, Francis Barlis and Megan Hendrick over there, for both their assistance in this paper and the different components of this paper. This summarizes a couple different studies and a number of different ways of looking at data cleaning and bias and covariance. We'll see if it works. Green, big green, right? Wait 3 seconds. There. So we've often found that people have issues with data quality in their surveys, especially when using opt-in non-probability sample and maybe even river sample, as we've learned today. And they oftentimes will argue that they should clean data before they analyze the data. And in cleaning data, in the opt-in world, cleaning data means eliminating cases, whole case deletion. One concern has often been with opt-in non-probability sample is about the suboptimal, less than accurate responses. Satisficing is one form of that, but it could be a dishonest or mistaken response, an inattentive response. It could be an approximate response rather than an accurate response. Oops, big green. So there's many different ways of measuring suboptimal response. It could be speeding through a survey, non-differentiation of responses in a series of questions, item non-response, extreme or exaggerated responding on numeric entry when people are asked how many days in the past year did you do this, and they'll enter 500. So it's out of range sometimes. Failure at trap questions, and there's such things as consistency checks as well. So when we look at federal studies, you don't find that whole case data cleaning occurs, or it's very rare. Most often it's cleaning specific answers, a specific item cleaning that is done in federal surveys. But again, when you go to the non-probability opt-in world, you have a lot of times where you're using this whole case cleaning. And we're starting to see researchers who use probability-based panels bringing these habits of data cleaning and whole case deletion into the probability world with knowledge panel, as well as I'm sure it's done with Amerispeak, et cetera. That people are starting to think that they need to clean out their data before they analyze the data, and that they need to try to detect suboptimal responses. But there's been very little research on the impact of data cleaning on the results that you get. A lot of people believe that you clean out bad cases, you'll have better data. Maybe we should ask the question, how many think that's true? Clean out cases, have better data. Oh, nobody believes that's true. Oh, 1, 2, okay, there we go. Okay, maybe we should do a personality survey right there. So what we typically do is look at when data cleaning is used, we look at data results after the data cleaning. We don't look at them before the data cleaning. So what we're asking today is how much data cleaning is useful to reduce bias? How should we clean our data? Is it possible to do too much data cleaning? Could data cleaning affect the results for subgroups more than it does for an overall group? And then could data cleaning improve our analytic models? So in study 1, we had both a Ipsos knowledge panel in 2015. We had 1,297 completes, and a non-probability parallel sample doing the same online survey at the same time, 2,564 completes. We had a number of benchmarks that people would complete. So you'll see the different sources, and it had 30 benchmarks that we would compare the data to in the survey. To assess the bias, we calculated the average absolute deviation from the results we got on the survey to the benchmark and creates a percentage difference. And so we did the absolute value, and then we averaged across all the 30 benchmarks. Makes for a fairly simple measure. The first attempt to clean data, we used multiple criteria. I did this in a paper in 2015 as well, where we were looking at non-probability opt-in sample and using multiple criteria, as well as, so you look at looking at everybody, then cleaning people out on the basis of item non-response and speed, item non-response speed and grid non-differentiation, and then numeric extremity. So you get these flags, you eliminate based on flags and sort of the scoring on these flags of how bad or egregious the suboptimal responding was. After each round of cleaning, we reweighted the data, and I created these breaks of, eliminating nothing, eliminating 2.5%, 5% of the sample, the worst 10%, all the way up to 50% of your sample, to see if you could improve your data or what these would have in terms of implications for your data set. Another way of trying this is just to rely upon speed alone. I have found that suboptimal behaviors in general all correlate with speed. Oftentimes they don't correlate with each other, but they almost always correlate with speed of the survey. So in some ways, speed of completion of a survey is a reasonable proximate or proxy for suboptimal responding. So then another type of cleaning we did was just based on speed. The fastest 2.5% up to the fastest 50%. So it's the median of speed of completion. So the results, what we expected, what we might expect based upon what everybody believes, is that you can reduce the amount of bias. First, we would expect that knowledge panel, a probability-based sample, should have less bias than a non-probability sample, right? So you see the differences in lines there. And that you should see some dipping down as you eliminate more cases, and then some rise up as you start to eliminate, you sort of start cutting out the meat along with in the meaningful results. And you might actually get more bias by eliminating more of your sample. So that's the belief. You go around to this room today, you might say, that would be my belief too, right? I won't ask you to raise hands though, because I know only one person would agree with this. But what we found was a flat line. With knowledge panel, you eliminate 2.5% up to 50%, you have the same average absolute bias. No differences. But what's even more surprising is within non-probability sample, you eliminate 2.5% up to 50%, and you have no differences in average bias. You do not improve your data by cleaning your data, at least in this study. So then it leads, as we see here, let's see, the first one was using multiple criteria, and this is using single criteria. So again, no differences whether we use speeding alone or the multiple criteria. We found comparable results, no bias reduction with data cleaning. No bias reduction with data cleaning, with whole case. Again, item by item, there may be some specific reasons you may be interested in that. Study 2, very similar study, but some additional information that we could have here. Could we replicate the data? Could we look at specific subgroups within the larger data set? And would it affect regression models? Does it affect covariance, essentially, by cleaning? So here, we had a knowledge panel study of 3,300. We had 2 opt-in samples. I was doing one experiment looking at getting opt-in samples without any quotas, just fill my number, and it would be a very rough stratification, basically, and then filling with quotas. So you see one without quotas, one with quotas. And again, we use speed as the primary criterion. We used a number of different, 24 different benchmarks from a number of different sources. And here's we replicated the results. You see the opt-in, flat line, both opt-ins, flat line. You do not reduce bias, essentially. You do not improve accuracy by cleaning data with the opt-in samples, nor with the probability-based samples. But you do get this consistent difference between the probability-based sample in terms of lower bias than the opt-in samples. Okay, and that's to be expected based upon what John has found in other studies as well. Now, bias for subgroups. What we did is we looked at, since we had 24 benchmarks, we looked at specific groups for white, non-Hispanic, Black, and then Hispanic as well. What we found is, and this goes across the 3 different sample sources, knowledge panel for Hispanic was green, opt-in is green, you know, for the 2 opt-ins. You'll see that Black and white are lower bias. The Hispanic group is higher bias, and that's higher bias in both the knowledge panel and in the opt-in samples. So, but data cleaning does not really affect the bias. It only at the very top end, you start seeing curvature of that line a little bit, that you start actually increasing the bias by removing more cases. Okay, so hopefully it's showing you that data cleaning may be something we have to explore more deeply if we really want to do data cleaning. Then I looked at 2 different types of analytic models we had in the survey. The predictors of life satisfaction and the predictors of political party ID, political party identification. And so you see model 1, this is a simple multiple regression that we're looking at, where we have 2, 4, 6, 8 predictors of a single dependent variable for life satisfaction, and 2, 4, 6, 7 predictors of political party identification. Okay. And what we see here is that the R-square, the overall model R-square, did not improve with data cleaning. Improvement would mean that the R-square would be going up and hopefully not going down. So if you clean your data, you do not improve your analytic results, and you actually decrease your statistical power, you know, by cleaning data. You think about eliminating 50% of your sample, the significance values start to become less significant or no longer reach significant. Then we look at the specific betas for the items, the predictor coefficients. And these items were not all measured on the same metric. That's why I'm using beta here. But beta does not change. There's a couple near the, you know, if you look at and betas can range from -1 to +1. And you see that towards the middle of the distribution, where they're closer to 0, you're getting some distributional changes over as you clean with extreme prejudice, 40% of your sample, you start seeing the betas starting to shift around a little bit. But in general, the order of the betas remains the same, and there is no change in the betas, and there is no change in your covariance essentially as you increasingly eliminate more cases. Similar true with this life satisfaction. You see no changes here for, oh, I'm sorry. Life satisfaction was with KP, life satisfaction with opt-in. I'm just showing you one for opt-in. And then R-square for party ID, no changes. For R-square, no changes, no real changes for betas, maintains the same order, no matter how many cases you eliminate. So data cleaning, case elimination is not helping us here. And this is for opt-in as well. And so if data cleaning eliminates noise in the data, we would expect that some cleaning should eliminate data or eliminate bias, I'm sorry. But it doesn't. It doesn't. You know, this is something that maybe you believed coming into this room, and now hopefully you won't believe leaving this room, okay? You have to have a lot more evidence to show why you want to eliminate any cases, because any of your measures are not going to change in terms of their, improve in terms of their reduction of bias. What I tend to think is that why doesn't data cleaning reduce bias or improve correlational models? I think the fastest 1 to 2% of the sample is bad data. You know, I've looked at it and they are different than the rest of the sample. But 1 to 2% bad data does not affect your data. does not affect your point estimates, does not affect variability in your responsibilities, because if you look at the bad data, it's random. It's around the point estimates. And so therefore you're not detecting it in its influence. So it really doesn't eliminate changing point estimates. It doesn't change variances. It doesn't change covariances. Then beyond the fastest 2%, you're eliminating people just like the rest of the sample. And therefore you don't get any changes when you start increasing your deletions. So the fastest 10% don't differ than the rest of the sample. So it's like you're eliminating people without a real basis. The first, fastest 1 or 2% maybe. So my thinking is, if it helps you sleep at night, it helps your client sleep better at night, maybe removing a very small number is fine. They are the egregious ones, but it's not going to change your results one iota. Anyway, that's it. Thank you.